All right, we are back, and today we're going to do another scientific reaction to a science fiction movie. Today's choice is to complete the trilogy that I've done in two previous videos and talk about the science of Return of the Jedi. Now, I hadn't actually planned on doing this one anytime soon, but with the passing of James Earl Jones last week, I decided to bump this up the queue, mainly just so I could just say what an awesome presence in movies and cinema that James Earl Jones was. It's hard to imagine the Star Wars trilogy being anywhere near the success it was without his iconic voice as Darth Vader. If you want to get an idea of just how much of a difference it made, there are videos right on this website that show the rushes when it was just David Prowse's voice inside the suit. And no disrespect to David Prowse, who brought a lot to the role, brought that physicality, brought that presence, that looming presence that was so important. But when you hear his voice saying those lines, it sounds really stupid. And you realize that only with James Earl Jones' menacing, overwhelming voice was that character going to be as generational as he was. And so he made contributions to many other movies. By all accounts, he was an upstanding guy. And, you know, Field of Dreams and Coming to America and everything he was in. One of my favorite James Earl Jones appearances was at the end of Sneakers when he shows up as the head of the CIA. And it's quite a funny scene where he's sort of playing against his own character. 93 years is not bad innings. I hope I live to be that long and am remembered as well. But it is a passing of a legend. And so I decided to just go ahead and honor that legend with talking about the Return of the Jedi. So, as is usual with Star Wars films, there's a lot you can just take for granted. Spaceships don't make U-turns, you can't dodge laser blasts, blah, 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 blah. But as usual, when you dig into science fiction, you will find yourself stumbling across, maybe even accidentally, really interesting things to talk about. So there's quite a few things to get into here. Let's dive in. Return of the Jedi. Now, one of the things to mention here is my son, who you met in my last video, he's actually going through the Star Wars series right now. And my daughter and I have decided to show him the series in what is sort of like what was called on the internet machete order, where you show 4, 5, then 1, 2, 3, and then 6 in terms of the sequence. And then he can watch 7, 8, 9 if he wants to. But someone suggested this on an internet post, and I showed my daughter the movies in this sequence so that 6 was the final film that she watched. And I found it actually works really well. It really makes, when you have 1, 2, and 3 as a flashback and then 6 is the finale, one, you're not ending on that Revenge of the Sith, you know, horror show where everyone dies and it's also bad and evil. And yet, you know, I know a lot of people who watched Revenge of the Sith and came home and immediately put Star Wars in because they were so depressed by the end of it. But you also keep the surprises intact. That, you know, when Darth Vader says, "I am your father," then you go back to see 1, 2, 3 to see the rise of Lord Vader. And so it works really well. It also emphasizes the parallels between Anakin's journey and Luke's journey, that you see those overlaps. You see how Palpatine is trying to manipulate Luke the same way he manipulated his father. And while his father fell to the dark side, Luke was able to resist falling to the dark side. You see the differences in their character and the people they surrounded themselves with and their connections to those people. And the revelation that Leia is his sister actually works better when you do it that way, that you see it at the end of movie 3 instead of where at the beginning of movie 6, it's sort of like, oh, okay, she's his sister. Whereas in movie 3, you're like, wait, there we go. There's another. He has a sister. So it actually works really well. So I did want to have a little mention of that while I'm doing this, because I do think now that I'm bringing a second child up through that sequence of watching the movies, I just think it works really well. So if you have kids or grandkids or someone who's never seen the movies, I do recommend you give it a try. This 20th Century Fox fanfare will always mean Star Wars to me. I'm sorry, it's just, I don't make the rules.
Just relax for a moment. You're free as a carbonite. You have hibernation sickness.
I can't see.
Your eyesight will return in time.
I actually do like this. I mean, they do it for dramatic reasons, but this is something that has been talked about. I've mention the potential of cryogenic freezing in my 2001 video and in my review of the three-body problem. And one of the things I talked about was the all the health effects, short, medium, and long-term effects of hibernation and freezing like this. And in the last movie, they said that this was not a facility that was really for freezing people. It was just, freezing of carbonate, and they were sort of doing an experiment here to see if it would work. So I do, even though I don't think there's a scientific motivation behind here, I do like that this process has had an effect on Han Solo, and he doesn't just jump out and start fighting immediately.
You will therefore be taken to the Dune Sea and cast into the pit of Harkoon, the nesting place of the all-powerful Sarlacc.
Doesn't sound so bad.
In his belly, you will find a new definition of pain and suffering, as you are slowly digested over 1,000 years.
Second thought, let's pass on that, huh?
You should have bargained, Jedi.
There is no scientific basis, obviously, for something like the Sarlacc that digests people over a long time. There are occasionally things like the mating habits of the anglerfish, where males will come up and bite the female, and she will digest their mouths and their insides and then just leave them as basically a pair of testicles attached to her that can then be used to fertilize her eggs. So you do occasionally have things like that in nature where one creature will sort of absorb and take control of another creature. And there's been a lot of writing in the extended literature about what the Sarlacc does, how it works. It takes these people and preserves them, and it melds their consciousness with its own so it can torment them and so forth, which makes it seem like a pretty evil creature. I can imagine that if you were a creature in the desert, that you would want to keep prey sort of stored for a while, kind of like a spider, and able to digest over long periods of time, when it may be long periods of time between prey falling into your pit, and you may have to make it last for a long time. One of the things that is kind of cool is the depiction of the Sarlacc, that it has this pit leading in. A lot of people compare that to the larval antlion, which digs a little pit in the ground, and then ants will come in and they fall into the pit, and then it's grainy and steep, and so they can't escape. So they eventually exhaust themselves and fall into the mouth of the antlion. And we basically see that happening with the Sarlacc, that once they get into the pit, Lando is trying to climb out and he really can't, because it's too steep. So in a galaxy of billions of creatures and all kinds of imaginative things, it doesn't seem that unrealistic to me that you might have something like this. And we have no terrestrial equivalent, but we have things on Earth that if you sort of cobbled them together and squinted your eyes, you could imagine maybe evolution could do this in a few billion years. So I'll allow it.
You can see here the Death Star orbiting the forest moon of Endor. Although the weapon systems on this Death Star are not yet operational, the Death Star does have a strong defense mechanism. It is protected by an energy shield, which is generated from the nearby forest moon of Endor. The shield must be deactivated if any attack is to be attempted.
So this is one of the big scientific questions I had when I was going over my notes, which is, how exactly does the Death Star's orbit work here? Now let's just consider Endor as essentially a planet. It's quite large compared to the Death Star, and the gravity seems to be very similar to Earth, so it must be of similar mass and so forth. So let's say it's kind of Earth-like in size and mass. There are many different orbits you can have around a planet, but the closer the orbit is, the faster you have to be moving. I mean, you think about it, the way orbits work, we've talked about this many times, that you fall towards the planet, but you're going to the side so fast that by the time you fall, you've gone around the arc of the planet, and you're in this perpetual fall where gravity is pulling you down, but your orbit is keeping you going sideways. The further out you get from the planet, the slower that orbit needs to be stable. The size of the orbit grows, but the gravity is falling off faster. The size of the orbit is growing linearly, 2r, whereas the force of gravity is falling as r squared. So the further out you are, the slower you have to be moving. Low Earth orbit is about 17,000 miles an hour, I think, and geosynchronous orbit is at about 7,000 miles an hour. Now, that's the problem. The Death Star we see here in this depiction and we see in the visual depictions in the movie is very close to the surface of Endor. That's a fast orbit. So if it's going to stay over the same part of Endor, in order for the shield projection to work, Endor has to be spinning really fast. Your day-night cycle on Endor would have to be about an hour in order for you to keep up with the Death Star's orbit. A geosynchronous orbit is where your orbital motion matches exactly the rotation of the object, but on something like Earth, that's thousands and thousands of miles away. It's much higher orbit, so you'd be sort of way out here, not very close to the surface of the planet. So basically, you have a choice here. You can have an orbit that's close in, where the planet's rotating really fast, or you can have an orbit that's pretty far out, where the planet's rotating normally. Now, the night-day cycle on Endor seems to be somewhat comparable to the 24-hour cycle we are used to. We see lots of events happening during the day, and then it's nighttime, and then it's daytime again. So, let's say 16 to 30 hours, something like that for the day-night cycle. And so, that's a problem. I've seen some people try to resolve it by saying, well, it's using repulsors to stay over the surface of the planet. Well, that's not going to really help you because the planet is still rotating, so you need to be rotating with it. And so this seems like an enormous waste of energy when you could be out here, just extend your shield way far out. Just doesn't look as visually striking. Simply hovering over the moon, turning on anti-gravity generators or something like that, isn't going to work either. You need to move with the moon as it's orbiting around its parent planet and as it's rotating on its axis. If you were to turn off the influence of gravity or turn off the orbital motion, what would happen is that either the planet would race away from you at thousands of miles an hour, or it would smash into you, which would deal with your Death Star problem, but wouldn't be very good plot-wise. You can't really have the Death Star using propulsion to keep it in this orbit, because as you add velocity or change velocity, you're changing the orbit. So it's not going to be in a stable orbit. So that's not really going to work. Orbital mechanics work in ways that are very non-intuitive to those of us who are earthbound. But trust me on this, if you're constantly accelerating or decelerating the Death Star, not going to work. But I thought about this quite a bit, and I did come up with one potential way everything could work out, and the Empire isn't stupid. I mean, the Empire is stupid. They build Death Stars and they get blown up by the rebels, but not totally stupid. And that is that this is a three-body system. Endor is not a planet, it's a moon, orbiting presumably a gas giant. And so with this, there are going to be Lagrange points around the planet. Just like there are Lagrange points around Earth or Lagrange points around Jupiter, there are Lagrange points around the moon, there are going to be Lagrange points around Endor. What are Lagrange points? They're where the gravitational force or the motion of the orbit exactly balance so that an object can stay in that orbit for a relatively long time with very little expenditure of fuel or no expenditure of fuel. Where are those Lagrange points located? Well, let's say you are Endor's planet. This is Endor. One of those is between the two bodies, depending on their ratio of masses. One is along the line. One would be in back of your head. And then two would be 60 degrees along the orbit of Endor. Now, this is clearly not 60 degrees along Endor's orbit, so it's probably one of these Lagrange points that's either between Endor's planet and Endor or behind Endor, lined up with the planet. So how does it work with the day-night cycle? How does it work with keeping the same part of the planet staying there? Because even if you're a Lagrange point, the planet's still spinning, right? Well, here's where it gets fun. Let's say Endor orbits around its planet in about 30 hours, let's say. And it's also, just like the moon, tidally locked so that it rotates on its axis about every 30 hours. So as it's moving around its planet, it is rotating. The Death Star is staying in its position. This alignment is staying exactly right because it's in the Lagrange point. But you get that day-night cycle of the planet. To Endor, it just looks like the sun's going around the sky and the Death Star is staying in the same, but if you could look at it from above, what you would see is Endor's planet, Endor, the Death Star, rotating like this. Once every, say, 30 hours, so that you get a 30-hour day, You get that synchronicity between the Death Star and Endor and its planet. Now, that seems like an amazing coincidence that you would get something like this. But we do have these kind of synchronicities in our solar system with the Jovian moons, where we have these ratios between their orbits. Earth's moon spins on its axis once every time it rotates around the Earth. It would be a rare feat to have the synchronicity just this perfect, but you're the Galactic Empire. You have billions of planets available to you. You can find something that's going to work out this way. Being this close to a gas giant where the orbit would be this fast would mean other consequences. The tidal stresses created by the parent planet's gravity would be very strong. Io and Europa, for example, are very close to Jupiter, and it stirs up volcanic activity deep in the planet. Io has something like 400 active volcanoes. And if you have oceans on Endor, you're going to have huge tides and so forth drawn by this heavy tidal force. Now, it looks like from the diagrams that Endor does not have a lot of oceans, so maybe that's not a problem. So there's no perfect solution, but this works pretty well. Now, as for putting the Death Star here, I actually think this is a good idea because you're in the shadow of this gas giant. So you're going to be difficult to pick out. If a spacecraft comes through the system, they may not see you right away because you're concealed by this massive gas giant. You're a satellite of a satellite of a satellite, so they may not see you. You're sort of in the radar shadow. It's also good because as in the extended literature, we find out that big gravity wells, like say a gas giant, can cause problems for warp drives and can make it difficult for people to escape. Now, we do find out later, of course, that the Emperor has let them know where their Death Star is to draw them out for an attack, which suggests that he hit it a little too well and they couldn't find it right away. So he had to say, hey, here's where I am. Please, for the love of God, don't come attack the Death Star. Of course, Admiral Akbar, the genius of the galaxy, falls right into his trap, but we discussed that in another video. That's a wonderful shot, but if it's in darkness and the Death Star's up there, it should be in the shadow of Endor, not illuminated by the sun or the gas giant like that. So they've got the shadows wrong again. That was the first thing I said in my Star Wars video about getting the shadows right.
Fulfill your destiny and take your father's place at my side.
Never. I'll never turn to the dark side. You failed, Your Highness. I am a Jedi, like my father before me.
Watched this movie about 1 million times, and I still love that moment. But this is when I talked earlier about the machete order. This is one of the things that I think watching the prequels sort of in between movie 5 and 6 really enhances both movies. That now when you watch that prequel trilogy, you can see that Anakin had a very similar choice to make, and he fell. He killed Dooku. He killed Mace Windu. When he was faced with these choices throughout his career, really, he constantly chose to do the wrong thing, whereas Luke chooses to do the right thing. And I'm sure someone can write long volumes about the differences in their character and upbringing and so forth and why, but the parallels between their journeys, and this is where their journeys diverge, I think is really a strength when you watch the movies in that direction. I have a genuinely higher opinion of the prequels than most people in my age demographic do, and this is one of the reasons that when you watch it in that direction, the parallels, the overlaps between the movies are much stronger, and I think improves the prequels tremendously. I'm not sure why you would have a tunnel that goes all the way down into the Death Star reactor, but the Empire's never been one big on OSHA regulations, so I do not like the adding of the no there. But it is a great moment, and thankfully they didn't poop on that in later movies and show that Palpatine somehow survived. All right, so you have this explosion. One of the things that has been talked about in the online fan base is this idea of the Endor Holocaust. You blow up the Death Star, and what happens? All that debris rains down on the planet, and you're talking about an enormous amount of energy being injected in the planet. You're talking about chunks of debris coming down with the impact of a meteor. If you just look at sort of the orbital energy of the moon, I ran this calculation earlier today. The moon's orbital energy, if you were to smack the moon into the Earth, just divert it and drop it down, would be equal to 1,000,000,000,000,000 billion Hiroshima bombs. Now, the Death Star is much smaller than our moon in terms of both size and mass, but it's also moving at a higher velocity because it's closer in. So it's going to have, something in that ballpark of energy. So let's say it's not 1,000,000,000 billion Hiroshimas. Let's say it's just 1 billion Hiroshimas. You're still talking about a massive amount of energy as this debris rains down on the surface of Endor. At the very least, you're going to have a severe case of Kessler syndrome. Kessler syndrome is a theoretical thing where you have so much debris in orbit around the Earth that it makes it impossible to do spaceflight anymore. You create these chain reactions so that the orbital space above the Earth is just filled with junk and you can't safely launch anything anymore. And there are actually real concerns that this may happen to Earth. We have a lot of stuff out there and a lot of space debris. When things hit, they're hitting at an orbital speed of thousands of kilometers an hour. And so they create this cloud of debris. You may remember I think it's about 20 years ago, China did this experiment where they brought a satellite up to another and it exploded it. And now we have thousands and thousands of these satellites going up for Elon Musk's Starlink and so forth. And he says he has a system that will enable him to evade collisions. But the more stuff you have up there, the more danger there is. You're going to have, at the very least, a massive space debris problem around Endor. I mean, Star Wars ships have shields and lasers, so maybe they can work around it, but whatever. You also have, with the Death Star, you're going to have, I'm guessing the Empire is not very compliant with OSHA and EPA regulations, so you're going to have toxic chemicals raining down. You're going to have all this metal raining down. Now, I've seen several ways to work out of this. One is that, well, it created this hyper wormhole and sucked all the debris in, and it went off to the side of the galaxy and so forth. We don't really see a lot of evidence of that. And it seems like a sort of retcon to me. This seems to be what Rise of Skywalker embraced, in that we see a major chunk of the Death Star on another planet in some other part of the galaxy, and God knows how it got there. So maybe, I guess. Another thing I've heard is that, well, it vaporizes the Death Star. That's a meaningless term. Vaporize just means you turned it into little particles. So instead of big chunks of debris raining down, you have this ash of particles from the Death Star raining down. That's almost as bad. It's going to heat up the atmosphere dramatically. You're talking about global warming on steroids, followed by a nuclear winter. It's really bad. So, vaporized, that's a term a lot of science fiction movies like to use, where they shoot something and it vaporizes and then they fly through the explosion and everything's fine. Matter doesn't work that way. It doesn't convert to energy just because you shot it. And so just because you blew up the Death Star doesn't mean all that mass is going to disappear. Probably the only real explanation is that the rebels actually did have a contingency plan for this, had a shield, had a tractor beam, had ships ready to clean up the debris from space before it hit the planet, whatever. Or there was a Endor Holocaust, one of the two. Because that amount of debris with that energy in that kind of explosion around a celestial body is going to be a problem. And you can't just wave whatever science at it you want at it and make it go away. So hopefully they did something about that, or else all the Ewoks went extinct. And I know a few people who wouldn't object to that too much, but I would. Look, this is probably my least favorite of the trilogy. It wraps things up a little too neatly, and I don't like that he sort of forgives Darth Vader for all these horrifying things he did while he was Darth Vader. I understand in the theology of Lucas's universe that he has changed back to a good person who is not responsible for the things the bad person did, blah, blah, blah. But it still bothers me a little bit. But even as my least favorite of the trilogy, it's really still a great film. This came out in 1983. I was 11 years old. I probably saw this movie in the theater about 987 million times. And we used to go almost every week. This was back before VHS and DVDs and all that stuff. So the only way you could see a movie if you wanted to see it many times was to go back to the theater. As I said in my first Star Wars video, Star Wars is fantasy with sci-fi trappings. It's not really sci-fi. And you're going to drive yourself crazy if you try to apply scientific principles to a Star Wars movie. But as with the first movie, I really like that George Lucas gives us, again, a big universe with tons of planets, tons of variety, tons of aliens, infinite variety. He has a galaxy that feels big. We don't go back automatically to the places we went in the first two movies unless there's a plot reason. Jabba the Hutt, being the gangster for us, go back to Tatooine and so forth. We don't go back to Hoth just because, hey kids, you like Hoth? That's one of the things that Lucas does better, I think, than almost anyone except for maybe Filoni with the Star Wars ethos, which is expand the universe, make it bigger, make it bolder. You've got billions of planets. You don't have to keep returning to the same ones every time. You don't have to keep returning to the same environments every time. You don't have to always have desert planets or ice planets or forest planets. You can have a variety of planets. Let your imagination run wild. That's why I got so into the weeds on this Endor thing, to think what kind of planet-moon combination could you have that would make all the dynamics work out, because Lucas has a big universe. If you can imagine it, it can exist. And that's one of the things I have always loved about the Star Wars universe. And when Star Wars makes itself bigger, makes its universe bigger, expands, takes advantage of the fact that we live in a giant universe with almost a doubtless endless variety, that's when I think it does well. And that's one of the things I think this movie does well from a scientific perspective. I'm glad to finish out this trilogy, glad to at least be able to acknowledge the contribution that James Earl Jones made to this universe after his passing. And hopefully I'll get a chance to do some more Star Wars stuff in the future. But we'll return to other things in my next video. Until then, I'm Mike Siegel. I'm an astrophysicist. I write for Ordinary Times. Thank you for watching.